Yes, the last time we looked at how we use the standard derivative formula to find the derivative of functions. But today we are going to be looking at sum and differences of some functions. Like examples, if you're having y equals to this, y equals to this, and y equals to this. We see differences and sum in the operations that are there. Now, if you're having this, what we needed to do is just to differentiate each of the expression. Then we add them or we subtract them from one another. That's exactly what we are going to be doing. Now we are going to be using the standard derivative formula. Let's look at number one. Says we should find the y dx if y equals to 2s raised to power 3 minus 5x raised to power 2 plus 2. We want to find the y dx. Now, if you want to find the y dx here using the standard derivative formula, we are going to be having our dy all over dx to be equals to, then the power here will multiply this one. 3 times 2 will have 6s. From the 3 minus 1 you have 2. Then minus the power here will multiply this one. 2 times 5 you have 10x. From the 2 minus 1 you have just 1. Then if you differentiate any constant you have 0. Now from here our dy dx gives us exactly this. Now, number two, if you're asked to find the y dx when y equals square root of x plus 1 all over square root of x minus 3. Now, if you want to find the y dx here, you are going to be differentiating each of these. Then you add them or you minus them from one another. So here, our y equals, we are going to be simplifying the square root first. We know the square root means, according to indices, it means raised to power half. Then the square root in the denominator 2 also means s raised to power half. Then minus 3. I want to arrange it so that it will be in a linear equation. If you do that, we'll be having y equals s raised to power half plus, if this one goes up from indices, it becomes s raised to power minus 1 all over 2 minus 3. Now it is not in linear equation, so we can easily find our dy dx here now. So our dy all over dx equals, the power here is half times 1. Here you have half x. From the power minus 1 from it, half minus 1, you are going to be having minus half plus the power here is minus half. Minus half times 1 here will give us minus 1 all over 2 x. Then from minus half minus 1 minus half minus 1 gives us minus 3 all over 2. Then we have seen from the first example that if we differentiate a constant, we are going to be having 0. Now from here, when we simplify this, dy dx will give us 1 all over 2x minus half. Minus times plus gives us minus 1 all over 2x raised to power minus 3 all over 2. Now I want to also remove the minus that is in the power. From what we have seen before, we know that minus becomes 1 all over the reciprocal of what is carrying the minus will go down. So our final answer, dy dx, is going to be giving us 1 all over 2. All of this will come down. X raised to power half, that is square root of x, minus 1 all over 2. All of these 2 will come down because of the negative here. So we have square root of x. Then the numerator is the power raised to power 3. So here now, this gives us our final answer as our dy dx. Now with this, now I believe you can solve more of any sum and difference. That's why the number 3 here will be a take home. So try and do this number 3 here. And let me see whatever problem you're having in the comment section, or your suggestion or your questions. Go to the comment sections. I'll see you next in my next video. Have a wonderful day. Bye.